Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 2 from Chapter 7, which is looking at graphing absolute value functions. So to sketch the graph of an absolute value function, say y is equal to the absolute value of some sort of function f of x, there's two options that we can consider for graphing. So the first one is to create table values, and within those table values, you would directly apply the absolute value. Or in the second method is where you sketch just the regular function, just f of x. So remove those absolute value brackets, and then you reflect the pieces of the graph that would contain any negative y values. So say if we were to have just a little rough sketch of a graph here, and maybe we had say maybe a diagonal line here. This one here would be, say, the regular function, y is equal to f of x. And so what would happen is if we were to take the absolute value of that function, anything below this x-axis here would become positive. So that's where it gets reflected. So say if this point right here were to be, say maybe it's -1 and -1. So what happens is that your x value stays the same, but then your y value becomes positive. So then what happens is that this would go directly straight up to x is equal to -1 and y is equal to +1 there. So that there would be -1 and +1. So your x value stays the same, but then your y value becomes positive. So anything that is already above would stay the same. So this here would be your left side of the graph, and then this would also still be your right side. So this part here doesn't change at all, okay? And so one thing that's really important is that when we're graphing these functions, it's really important to see this little intersection point where you have your negative, or where you had to apply your absolute value, and then where it stayed the same. So you have to show this little intersection point here on your graph. And so that intersection point will always be at the same y value, and that's always when y is equal to 0. Because anything above 0 is positive, so that would stay the same, like anything to the right here. Or if it was negative below 0, that is where you apply that absolute value, and then you would have to reflect it about that x-axis. So in this video, I'm going to show you how to graph just using a table of values. So I'm not going to show you how to sketch the graph given the actual graph of the original function. And so this one here is example number 1b from your notes. So here we're going to sketch the absolute value function y is equal to the absolute value of 2x minus 3. So as I just said, we need to make sure we show this little intersection point on our graph. So what we need to do is we need to find that value, and then that'll go in the middle of our table of values. Then we'll choose a couple values above, a couple values below. So as I said, this value right here is when y is equal to 0. So let's let y equal 0 in our equation and solve for x. So we have 0 is equal to the absolute value of 2x minus 3. Then what we can do is, it's really hard to solve for this when we have those absolute value brackets, but we can actually remove them, because as long as we solved our solve for x correctly, this should give us 0, and the absolute value of 0 is just 0. So that means that we can rewrite this as 0 is equal to 2x minus 3. Then we're going to solve for x. So we're first going to do the opposite operation here. So if this is subtract 3, you want to add 3 to each side. So then you'll get 3 is equal to 2x. And then we want to get rid of this 2, so we're going to divide each side by 2. And then our answer here for x is that we have 3 over 2. Or if it makes your brain a little bit happier, you can also write this as a decimal form. This is 1.5. I personally find it easier to graph decimals rather than actual fractions. So if it makes your life a little bit happier, makes your brain happier, definitely go with this decimal value. So this value here is where we'd have that little intersection point where our graph will reflect. So that goes in the middle of our table values. So I'm going to put 1.5 right here. And then we know that that would give us a y value of 0. Then what we can do is then we'll choose a couple values above and a couple values below this x is equal to 1.5, just so that we can graph it and have a good idea of what's going on. And so in terms of values, I would recommend choosing values that are the same distance apart, and also choose values that are easy to work with. So don't choose 1.75 or 1.25 or even 0.5 because decimals are just gross. So choose really nice numbers. Just make sure that they're about the same distance apart when you're going above and below. So what I might do is I might go down. This is 1.5. I might go down to even say 0. So this one here has a difference of 1.5. So if I want to go above, I might want to add 1.5 again, so I'll get 3. And then you don't have to add 1.5 each time, just as long as you're the same distance away from this 1.5. So maybe we can go down one value from 0 to give you -1. And we want to go up one value from 3 to get us 4. And these ones here are just values that I'm choosing. So this, you might choose values that are a little bit different, but all in all, our graph should look almost exactly the same. You just might have smaller or bigger values. So once when you've chosen those values, now you can actually plug those into that absolute value function and solve for our y value. So our function here was absolute value of 2 times x. So here we have 2 times -1 minus 3. So 2 times -1 is -2 minus 3. And -2 minus 3 is -5. So here we're going to have the absolute value of -5. When you apply that absolute value, you find that your y value will be +5. So this value right here, this -5, if you were to graph the original function, so one that didn't have the absolute value, this here would be your actual value. So it would be -5, and then you reflect it across the x-axis to get +5. And now we're going to basically copy, paste, and repeat for all the rest of these values until we have all of those y values. So here we have 2 times 0 minus 3. 2 times 0 is just 0, so we have 0 minus 3. And what we find is that we have the absolute value of -3, which is then equal to +3 when we apply those absolute value brackets. So now what we need to do is we need to fill in the rest of our table values here, and that's on the opposite side of your little x or y is equal to 0 portion here. So that's the middle of your table values. And if we do our work rate, what we should actually see is that we should have it should almost be like a mirror image of what's going on our left side of that graph. So here we should, if we're choosing the same distance apart, this value should be +3, and this value here should be +5. So if we've done our work right, this should be a reflection, and so we should have those points mirrored points. So it should almost be very similar to what a quadratic or a parabola would look like. But this time, though, instead of a U-shaped, it's a V-shaped. So it's a pointy vertex rather than a nice curved, smooth U value like the parabola would have. So let's plug in this value of 3 here. So here we have 2 times 3 minus 3. 2 times 3 is 6, so we have 6 minus 3. And 6 minus 3 is +3, so if we apply that absolute value, it actually doesn't change it. So 3 stayed as 3 here. If you notice here, we have those mirrored values, which means that we're probably on the right track. I would recommend, though, doing the work every single time, just to make sure that if you didn't, maybe if you made an error, and these values, maybe for 4 and -1 didn't match, that would tell you made an error. So I would always caution you to always do the work, and then that'll help confirm that you did the work right. So here we have the absolute value of 2 times 4 minus 3. 2 times 4 is 8. So we have 8 minus 3, which is +5. So now that we have our values, now we can go ahead and graph. So what we need to do, our first step here is we need to label our x and y axis spacing. So I'm going to first just consider our x values. And here we need to get -1 and as high as +4 on your graph. So here I'm just going to count my spacing here. This part here will always be my origin, so that'll be 0. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So I can make every second line equal to 1. Then I'll also want to go in the negative direction as well. And then for my y values, here I want to see as small as 0 and as high as positive 5. And so here, counting up our lines here, we'd have 10 as well, so we can actually do the exact same spacing. And one thing, if I can caution you when you guys are graphing, just make sure you guys are using at least half of your graph or more, just so we can see a proper graph and really tell the trends in the data if we were to ever be asked that type of question. But so in general, try and use at least half of your graph or more if that's possible. This kind of graph does limit us a little bit because it shows us our x or the negative y values, and because our origin is already in place. So here we might actually only end up using the first quadrant, but try and use up as much as you can rather than having it really squished in, meaning like a little corner here. Okay. So once when you've labeled all your values, then you can go ahead and start graphing. So here our first point here was -1 and 5. So you're going to go over to x equal to -1 up to positive 5. Then we had 0 and positive 3. Then we had 1.5 and 0. Then we had 3 and positive 3. And we had 4 and positive 5. So when you're connecting your points, just remember that with the absolute value function, that's going to create a V-shaped graph. So you don't want to have it a smooth, rounded corner at that vertex. So it wants to be straight to that 0 value and then go straight out to connect to the rest of your points. So it should be in the shape of a V, not a U. You should also use a ruler if you can. Obviously, I can't put a ruler on my computer, so I'm going to have a little bit of a shaky hand, but that should be a very straight, smooth line. And so straight out, going left and right. And at this point here, your vertex, which is also your x-axis, or x-intercept, that there should be a pointy or a sharp turn, so there should be no smooth curve. So once when you've done that, make sure you put arrows on the end of each of your, on each of those ends of the graph. And then you guys are all done. So that is everything here for this video. So thank you guys so much for watching. If you guys have any questions, make sure to come see me in class, or you can text me on Remind 101.